Hello and welcome everyone. It's Elias with you guys again. Today we will be discussing discrete structures exam number 6. I'll quickly read the problem and then we'll get right into the code. So today we had a problem that says write a program to demonstrate the number of people needed to ensure that the probability that at least 2 of them have the same day of the year as their birthday is at least 50%, 70%, 80%, 90%, 95%, 98%, and at least 99%. Okay, so for this code, I went ahead and used what we used in class. The example given to us, as you can see here in PyCharm. I have what my program is. Like I said, much of this is what we saw in class. So we'll go ahead and run it. And I ran the numbers already, and we did, we're doing out of 1,000 tries or out of 1,000 rooms, for example, and we're going to take in people in the room. We're going to type that in by us, take that input ourselves, and we'll run those numbers. So I did run some tests prior to this and found out that we do, let me go ahead and run this so you can see. Okay, right here. So we do need 23% to complete that first 50%. So if I run anything below 23%, we would get numbers less than 50. So we do need 23 people in the room to at least get that 50%. Our second number that I saw, if we run this again, we needed I'll pull this side by side. So I hope you guys can still see that. Yeah. It's a little smaller, huh? Give me 1 second. Pull this all the way up. Switch this to this other screen. Okay. So our second number that was given to us that at least 70% that 2 people have the same birthday. So in order to do that, I ran the numbers and I had to have at least 30 people in the room to at least have a 70% probability that 2 people have the same birthday in that room. Any number less than 30 would give us less than 70%. But we wanted 70, so 30 is the very minimum. Jumping to our next number, we wanted 80%. For 80, the number was 35 in a room to at least get that 80% that we want. Our next number was 90%. To get 90%, we had to have 41 people in the room to get that 90% and above. I mean, one number less and it'd be a little bit, sometimes it would get close to 90 if you round up, but we didn't want to round up. We wanted that number or above, so we went with 41. Now if we wanted 95%, that number, people in the room, would be 46 people in the room to get that 95%. Well, as you see here, sometimes it's a little bit below, but it's like right there on the verge. So we could say like a 46 or maybe a 47. We'd go with a 47. Run that really quick. That would give us 95. So honestly, it would be 47 just so that we don't get less than the required, which is 95%. So we'll go with a 47 to get that 95%. They also wanted to know 98%. 98%, I found it to be at least 54 people in a room. So we have that right here. At least 98% has to be 54 people in the room. And the last number was at least a probability of 99% that 2 people in the same room share the same birthday. And for that number, we got number 50, or 58, sorry, didn't mean to type 5. We needed at least 58 people in the room to have a 99% probability, 99% chance that 2 people in the room have the same birthday. And with that, we conclude our homework for discrete structure 6. As we can see, we discussed this over here, saying that we needed at least 50%, 70%, 80%, 90%, 95%, 98%, and 99%, which the numbers for 50% was, and I'll repeat, for 50% we needed 23 people in the room, for 70 we needed 30, for 80 we needed 35, for 90 we needed 41, for 95 I had 46, but we actually need 47 to be at least that number or above. For 98 we needed 54 people, and for 99% we needed 58 people in the room. And with that, that concludes this session. Thank you guys so much for watching, and we'll catch you in the next one.